I am Sampurak Talukdar of Section 2 DIY Group 1. My roll number is 20CE10060. For the DIY assignment 4, we have two tasks. So for the first task, we have these two motors in channel A and channel B, but we will be only considering and concerned with the motor in channel A. So first I will start off by describing the input and output pins related to this motor. This input 1 pin is connected to the IO12 pin of the Arduino board, and this also goes on to define the direction, that is counterclockwise or clockwise, in which the motor will rotate. This input 2 pin is connected to the XNOR gate, which is connected to the IO12 and IO8 pins, and we will be keeping this IO8 pin in low condition, that is to keep the brake, and this IO12 pin in high condition because we want this motor to rotate in clockwise direction. And this enable A pin connects to the IO4 pin, which in turn connects to the IO6 pin, and in this IO6 pin we will input the value of PWM, that is the value of the input voltage signal, which in turn goes on to determine the RPM at which the motor rotates. These out1 and out2 pins are the output pins of the motor, and these complete the desired circuit. This is the source code that we have written. These are the instructions for the values of the input and output pins. Here we have defined the PWM variable. Here we input the PWM value in the pin 6. The max PWM is 255. If PWM is 255, then it means the voltage signal is high for all time, and if it is 0, then the voltage signal is low for all time. So with these settings, now we can proceed to the animation. So first we start off. As we can see, the motor has started rotating with a steady increase in the RPM. This value will increase till it reaches a certain value. As we can see, the value has reached its peak, which is 35, and this is the RPM that we get for PWM 200. So we stop the simulation. Now we input a different PWM, which is essentially half of the previous PWM, and we build the project. So after compiling, we again run the simulation and wait for the value to reach its peak. For half the PWM, we should expect an RPM which is essentially half the previous max RPM. However, instead of a value somewhere near 17.5, this time we see that the value peaks somewhere near 9.27. This is because of the fact that this motor doesn't represent an ideal motor, but represents a practical motor, that is the motor which we use in real life. So there is a difference between the expected and obtained values of the RPM. That is why in real life, instead of open loop system, we use closed loop system to obtain a desired value. So we stop the simulation. This is the end of task 1. We can head over to the second task of this week, which is creating a virtual dashboard using sensors and gauges that represent the value obtained by the sensors for different physical quantities. So in this Node-Red canvas, first of all, from this dashboard we have selected two sliders which have been labeled as the water level controller and the gas pressure controller. And then first of all, we have selected a gauge for the water level, and then we have selected a chart to represent the gas pressure value. As you can see, these are the settings. We have set the max value for the gas pressure controller is 40 with step values of 1, and for water controller it's 100. And then we have given different color settings and other settings for these charts and gauges. So we can head over to the Node-Red dashboard UI, which shows the values obtained by the sensors in the form of this marker or this chart. In real life, these values are supposed to be obtained by sensors, but as here we are representing a virtual environment, so these values we have to input ourselves. As we can see, with different values the marker moves representing the value, and so is same for the gas pressure. As we can see, we can execute a real-time sync for this website on more than one device, that is 2 or 3 devices. For example, here I have taken my mobile and connected this website to it. So we can see that these 2 devices are synced. For example, if I change the value in my mobile, then it changes in the PC too, and same for this. So we can see that these devices are in sync. Thank you. That's the end of the task 2. Thank you.